In this video, we're going to review our properties of exponents. Most of these are actually really intuitive when you just kind of break down what they mean. But these first two are a little more, kind of have to take these as a definition. So when we talk about taking a number and raising it to the 0 power, we just kind of need to know that that's always going to equal 1 anytime that happens. So if I have 3 to the 0 power, that equals 1 just by definition. And then if I have a number raised to a negative power, or a variable for that matter, then that's the same as 1 over that number or that variable to the opposite of that. So this rule number 2 I like to just think of as if you switch the level of where your factor is at, whether it's on the top of a fraction you want to move it down, or on the bottom of a fraction you want to move it up, that changes the sign of the exponent. So, right, 3 to the negative 2 means 1 over 3 to the positive 2, which is 1 over 9. 1 over 2 to the negative 3 is equal to just 2 to the 3, with that being in the numerator, and that, of course, equals 8. This one's more intuitive. If I am multiplying two things of like bases, then I can just add their exponents. But let's just understand what's going on here. When you have something like 4 to the 2nd power, right, what does that mean? That means 4 times 4, right? And when you have something like 4 to the 3rd power, what does that mean? That means 4 times 4 times 4. So how many total 4s are there multiplied together? 5 of them, right? So I just add up how many I had here with how many I had here, and that's how many 4s I have multiplying together there. And then same sort of thing here, right? If you have x to the 16th over x to the 11th, that literally means 16x's multiplied together on top divided by 11x's multiplied together on bottom. And so you can just cross them out an x at a time, right? So x times x times x. I'm not going to write out all 16 of them, right? X times x times x. And you can just start slashing out x's from the top and the bottom. But of course, what's going to happen is here on the bottom, you're going to run out of x's way before you run out of x's on the top. And so when you're done crossing out x's on the bottom, what are you left with? You're left with 5 of those. Right? And so that's why it makes sense to subtract those. And then when you have a power raised to a power, we're just going to multiply those exponents. And again, what's going on here? Y cubed to the 4th means y cubed times y cubed times y cubed 4 times, right? So what are we doing? We're just repeatedly adding 3 to itself. What is repeated addition? Multiplication. All right. And then these last two here, if you have two things multiplied together, all raised to the same power, you can raise them to the power separately and then multiply. Same thing with division. So we can put all this together to simplify exponential expressions. So let's zoom in a little bit here and work on these two. So I want to write these as simply as I can. And so what I just want to do is identify the different properties that I'm seeing. So I see m to the 4th to the 5th. Right? So right off the bat, I know that I'm going to multiply 4 times 5. Right? And what am I using there? Oops, that's not the button I tried to push. I'm just using property number 5 there. Right? Now, when I just see an m here, you might find it helpful to recognize that's m to the 1st power. So I have m to the 20th times m to the 1 divided by m to the 10th. But we know when we're multiplying two exponential factors with like bases, we're just going to add 20 and 1 together. And then when we're dividing like bases, we're just going to subtract them. So all that cleans up to just m to the 11th. Part B here, I've got some negative exponents happening here. And notice that the bases are the same here. And the bases are the same here as well. So we can employ that subtraction property. Now, one thing that's nice is to try to anticipate how to do the subtraction so that you end up with positive exponents, right? Just cuts down on the work you have to do. If I go back up here, notice that you can either say that a to the m over a to the n is a to the m minus n, or you could go the other direction and bring the a to the m down in the bottom of the fraction and subtract the other way. So we have either of those choices at our disposal. So what we want to do is think of, if I move the smaller exponent, then that's what's going to give me a positive answer. So, of course, negative 2 is smaller than negative 1, so what I can do is say, all right, I'm going to do 5 to the negative 1 minus negative 2, right? So taking this one minus that one. But then on the other hand, 7 is smaller than 9, so I'm going to take that down to the bottom and do z to the 9 minus 7. So negative 1 minus negative 2 is, of course, just positive 1, z squared. So that one simplifies to 5 over z squared. All right. Now, if you had subtracted differently, it's not really that big of a deal because, you know, for example, if you went 5 to the negative 2 minus negative 1 instead, and z to the 7 minus 9 instead, you would have z to the negative 2 over 5 to the negative 1, right? But then remember that the second property just says you can switch the level by changing the sign of the exponent. So then I would just say, oh, okay, well then let's send this down and send this up. And we would end up with, of course, the same answer. So 5 to the positive 1 over z to the positive 2. All right, now let's just do two more kind of larger ones here. If you can do these, you can do any of them. All right, so now this one's a little bit tricky because what we've got going is basically a combination of two of the properties from the previous page. So if we look at property 6 and 7 on the previous page, this one says you can take the exponent through multiplication. This one says you can take the exponent through division. So here we're basically wanting to do both, right? Take the exponent through multiplication and division. So while you could try to approach this in a real step-by-step fashion, if you just have a big fraction like this, it's all multiplying and dividing, what's okay is just to go ahead and say, you know what, I'm going to take everything and raise it to the negative 2. Right? Just writing every one of those that are in those parentheses. Raising it to the negative 2. And then what I have is, well, 3 to the negative 2 and 2 to the negative 2. I really can't do much with those, right? But what I do know is I want, and I guess I kind of dropped the ball in saying this, so let me just say it now. Whenever we say simplify, this means write with positive exponents. That's implied when we're talking about simplifying. So I know that I'm not really happy with 2 to the negative 2, right? But I know that I can easily make that 2 to the positive 2 if I put it up on top. Same with the 3 to the negative 2. I can make that positive exponent if I put that on bottom. Now for all these other things, a 2 to the negative 2, remember this is a power raised to a power. So that means I'm multiplying these. Okay? So this is going to be a to the negative 4. This is going to be b to the positive 4, negative 2 times negative 2. C to the positive 2, negative 1 times negative 2. A to the positive 2, B to the negative 4, and C to the positive 8. Now with my numerical parts here, something like 2 squared, I need to leave that as an exponent, right? I can do better than that. 2 squared is 4, right? 3 squared is 9. And then here what we want to do is do that same analysis we did in that previous example. So I want to do some subtraction of exponents to get the A's, the B's, and the C's together. So the negative 4 is smaller than 2, so I'm going to move that down. Right? 2 minus negative 4. Negative 4 is smaller than 4, so I'm going to bring that up. 4 minus negative 4. And then I'm going to bring this down. C to the 8 minus 2. So that's really 4 plus 4, so 4b to the 8th over 9, a to the 2 plus 4 is 6, c to the 6th. Can't do any more simplifying, right? I have them all as one single variable to a power. 4 and 9 can't reduce at all, so that would be my final answer right there. All right. Just one more example. This would probably be a good one for you to just pause the video, try it yourself first, see how you're doing with these. But assuming you've done that already. Kind of a similar situation to our last one. I want to take everything raised to the negative 5. And just a comment I want to make here is that I can only do this distribution of exponents, if you will, because of the fact that it's all multiplying and dividing. If there were a plus sign in either the top or the bottom, a minus sign in either the top or the bottom, all bets are off. You cannot distribute through addition or subtraction. So it's only the fact that it's multiplying and dividing that allows us to make this initial move here. All right, so 4 times negative 5, that's negative 20. Negative 7 times negative 5, positive 35. Well, my 5 to the negative 2, right? I don't want to leave that as a negative, so I can bring that up. That's 5 to the positive 2. A to the negative 4, B to the positive 2. All right. So 5 squared, of course, is 25. Now, negative 20 is the smaller, right? So negative 20 is smaller than negative 4, so I'm going to do A to the negative 4 minus negative 20. And I'll do B to the 35 minus 2. So we end up with 25b to the 33 over a to the 16.